We are down to our last two videos for the first grading period. This is still on this concerned on the radical equations, or specifically in solving radical equations. In the previous video, we were able to determine the different processes that will be involved in solving radical equations. We are still going to copy those methods as we solve the different problem or practice exercises for this video. I have prepared 6 different problems with additional processes or concepts that may be needed in solving our radical equations. Again, our goal is to look for the value of x, which or x in case of the variable, because we are using the commonly used variable. But for general, we are going to solve or look for the value of the variable which can make the equation true. I'm going to share to you right now the 6 different items. So here are the 6 different items as compared to the items given in the previous video. You may check the previous video first before viewing this video, so that you will be guided on different processes. So the only difference in the previous video and this the I mean, the only difference between the practice exercises found in the previous video to this one, practice exercise B, is that your radicand here may appear to be binomial, meaning the radicand is in a binomial. We have two terms, because in the previous video we only have a monomial term for our radicand. But it will not change actually the processes that will be involved in our solution. Let's try to take number one. Square root of x plus 2 equals 7. Okay. In this case, in the previous video, we have a similar an example wherein it looks like this. So this example means that the integer 2 is not part of the radicand. And then we could actually automatically apply the laws, I mean, the properties of equality by subtracting both sides by 2 to omit this. That is for the previous video because we only have monomial term. But now this is a binomial. So my point here is you cannot or do not subtract 2 on both sides yet, because this is not an integer outside the radical expression. This is part of the radicand. So they will be treated as a whole. To do this, instead of subtracting both sides by 2, we can simply square both sides automatically. This is made to neutralize the radical expression square root here. And then next is we can now remove this, and we have left with x plus 2 equals the square of 7, which is 49. Now we don't have a radical expression. We can now use this is now an example actually of a linear equation. And you apply the properties of equality. We can subtract 2 both sides, 49 minus 2. And then our answer value is x equals to 47. Hey, again, we did not subtract both sides by 2 because, again, 2 is part of the radicand. It's not in a coefficient outside, it's inside. So we neutralize first our, I don't know if I'm using the correct term neutralize, but let me just use the word neutralize so that you could understand it better. So we are neutralizing the radical expression. And then we have this answer. So again, do not settle with this, always check. And where do we check this? Not here, not here, but we always check to the given. This would become 47 plus 2. 47 plus 2 is 49. Square root of 49, or you could actually check it here. 47 plus 2 is 49. Square root of 49 is 7. This means that this is not just an answer for the value of x, but that is actually, and more importantly, a solution. Okay, so we just simply use the same processes. So let's try to apply it in number 2. So you have here x minus 4 is equal to negative 8. So again, do not add both sides by 4 because 4 here is not an integer outside, but it's part of the radicand. So what you can do this here is to square both sides. And then we have removed the radical expression. Let me use the color. Then we have x minus 4 equals square root of, square of negative 8, or the perfect square of negative 8 is positive 64. And then apply the properties of equality. That's for both sides. 64 plus 4. So the value for x is 68. And then this is not yet a solution because we are not yet checking. Now we are going to check. That's C in number 2. 68 minus 4 is 64. Square root of 64 is positive 8. Okay, positive 8. Why? Because there is no negative sign here mingling outside the radical expression. Means we are taking the positive of the root of 64. In short, this answer here do not satisfy our given equation, and we can say that this is not a solution. If the answer or the value of the variable do not satisfy the given equation, it's an answer but not a solution. Okay? Let's not uh, uh, complicate ourselves. Solution is the only value of x which can make the equation true. Okay. Number 3. In number 3, you have the square root of x minus 4. Okay, in this case, we have positive 8. So probably we can get an answer here. So again, we square both sides. So you have x minus 4. Sorry, that's x minus 4. Minus 4 equals 64. And then you add both sides by 4. 64 plus 4. So this would become 0. X is equal to 68. Let's see if 68 here is now a solution in comparison to number 2. So in given number item here, 64 minus 4 is, 68 minus 4 is 64. Square root of 64 is positive 8. That satisfies the equation. This is a solution. Okay. Number 4. Our radical in number 4 is still a binomial, but we have a coefficient 2 for our variable x. Okay. Don't be worried with that. We just simply need to follow the steps that we have been using. Again, the 5 here is part of the radicand. So we cannot subtract both sides by 5, but rather we can square both sides. And then this would become 2x plus 5 is equal to 36. This is the time that we can subtract both sides by 5. So you have 2x plus 5 minus 5 is equal to 36 minus 5. And then you have 2x is equal to, you have here 31. Right? Sir, is it possible to get an answer which is a fraction? Definitely yes. As long as the number is a real number, it's still acceptable. Because when you divide both sides by 2 here, the value for x is 31 halves. Okay. So how do we check that, sir? If we that's 31 halves, you will apply a fractional form here. This would become the square root of, I'm just using the left hand side, 2 times 31 halves plus 5. And then you could cancel this out, cancellation law of multiplication, and you will have 31 plus 5, which is 36. And the square root of 36 is 6. Even if it's in form of a fraction, this is a solution. But again, I would like to emphasize, just for better reference as we go to higher level mathematics, if your answer is a fraction, please stay in fraction. Because if you will use here decimal, though you could still get the answer, but not all of us are more comfortable with decimal notation. Aside from that, if your answer is an improper fraction, please stay with improper fraction. Do not convert it to mix and say this is 15 and 1/2, because as you check, it will make this checking more complicated. So simply use the improper fraction. And of course, finally, always simplify. But since we cannot actually simplify this more on uh, another a fraction, that stays as it is. Number five. So number five, you have 2x plus 1 minus 3 is equal to 7. So take note of all the coefficients found outside. Those are the things that you could only manipulate first instead of the radicand here. Right? So we can manipulate this first by adding both sides by a 3. I'm going to cut my process, my solution here. So you have 2x plus 1. You add both sides by 3, that will become 0. And then 7 plus 3 is 10. Hopefully you are following. I'm cutting short some of the processes here. Okay. And then we divide both sides by 2. You have square root of x plus 1 is equal to 5. And then square both sides. You have x plus 1 equals 25. Moving it up here, up, you can subtract both sides by x, I mean by 1, sorry. So you have x is equal to 25 minus 1, 24. Okay, so the value for x is 24. But for before deciding whether it's a solution or not, check it using the given equation. So you have 24 plus 1 is 25. Square root of 25 is 5. But since the process here is multiplication, so 2 times 5, we have 10. And then we have minus 3, you have 7. Therefore, this is a solution. Okay. Down to our last item for this practice exercise B, we have here the cube root of x minus 12 is equal to 3. Similar to the previous practice exercise on number 6, it's now a cube root. So instead of squaring both sides, we can cube both sides. As to why we can automatically cube both sides, we don't have a coefficients or operations outside the radical expression because negative minus 12 or 12 here is still part of the radicand. And then as you cube that, you have x minus 12 is equal to the cube of 3, which is 27. And then add both sides by 12. X is equal to 39. Let's check. 39 minus 12 is 27. Cube root of 27, the answer is 3. And is therefore, this is not just an answer, but it's definitely a solution. So this is still on the radical equations. We are just uh, adding the concept of a binomial radicand. Okay, so same process are to be followed. So this is our second to the last video. We still have one more video, and thank God it's just one more video for the first grading period. And still on the radical equations, but we are going to add another concept for solving radical equations. But a part of the disclaimer, to which I'm also going to mention on the next video, we are just going to target basic radical equations. As to mean by basic, there might be some types or examples of radical equations that may not be covered by these instructional videos because they may be covered later on, but another concept in the second grading period. So be excited with that. Use this video as part of your review. Thank you very much for watching. Goodbye.